Good morning, Trig. We're going to cover lesson 55, which is kind of a nice break. It's pretty easy. So 55.A has to do with circular permutations. So a little review. When I have a linear permutation, then it's just the number of people factorial. For example, ways for 6 people to line up in a straight line equals 6 factorial, which I believe is 720. Now, a circular permutation is if we were sitting at a table. And so if there were 6, 5, 4, 3, 2, 1. If there were 6 of us sitting at a table, it's no longer 6 factorial, because when 6 people are sitting next to each other in a linear fashion, there is no one to the right of this person and there's no one to the left of this person. So we call this linear because you're in a straight line. Circular, every single person has someone on each side, so there are less ways that they can sit in order. So a circular permutation should be n minus 1 factorial. And that's it. So in this case, it would be 6 minus 1 factorial, which is 5 factorial. I don't have that memorized. 5 times 4 times 3 times, so 120. Okay, so we'll do 2 examples, and I think that would suffice. So example number, and these are like the ones in your homework. So example number 1, how many ways can 5 people A sit in a row and B sit in a circle? Okay, so they'd like us to do how many ways can they sit linear, right, all in a straight line, and how many different ways can 5 people sit in a circle, like how many different combinations. So part A, right, would just be in a straight row, so 5, 4, 3, 2, 1, or 5 factorial, which as we discovered above is 120. Part B, and because it's in a circle, it would be 5 minus 1 factorial, which is 4 factorial, which is 24. 4 times 3 times 2 times 1. All right, number 2. Let's say Michelle, which in my case is me, has 8 chips. You can think, if you want, we can think of this as poker chips or regular potato chips, whatever. Each a different color. How many ways can, I skipped a word, didn't I? My apologies. How many ways can I place them in a line, or B in a circle? So really simple, you've probably already figured it out. So part A would be 8 factorial, which that's 8 times 7 times 6 times 5 times 4 times 3. I got 40,320. And part B, right, it would be 8 minus 1 factorial, which is 7 factorial, 7 times 6 times 5 times 4 times 3. And I got 5,040. And then that's it for 55.A. So pretty simple. That's why I told you this section is kind of a nice break. So moving on to 55.B. 55.b is not any more difficult. This is distinguishable permutations. So distinguishable means different. Okay, so distinguishable permutations would be like how many different ways can I arrange the letters A, B, C? And different meaning I can't repeat any single order. So this section you will have to divide by the number of repeats. And this is actually a review from Algebra 2. We did cover this section there. So I'm going to do 2 examples with you, and that should be enough. So how many ways, actually I would say how many distinguishable ways can you arrange the letters in? Okay, so we're going to do a few. So part A, let's say I have the letters A, B, C, D. Okay, so for this example, I count up how many letters I have. So I have 4, factorial. And I would divide anything that repeats. Now in this case, no letter repeats itself, so my answer is just 4 factorial, which is 24. Now part B, the letters in my name. So M-I-C-H-E-L-E. So 1, 2, 3, 4, 5, 6, 7, 7 factorial. But if you'll notice, I have 2 letter E's. And so I have to divide by how many there are because they are going to create the same permutations. And we want distinguishable, so we don't want any repeats. So I have to divide by the letters that repeat themselves. So a couple ways you can do this one, right? You can do 7 times 6 times 5 times 4 times 3 times 2 factorial. Remember we went over how to do this by hand, so these cancel. And so in my calculator, I would just have 7 times 6 times 5 times 4 times 3, and that gives me 2,520 ways I can arrange the letters in my name. All right, so moving on to part C, let's do, I'm trying to think of a really good one. The letters in Mississippi. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 factorial. However, I have quite a few letters that repeat itself, correct? So the first thing I notice, I have 4 S's. So these are the S's. I also notice I have 1, 2, 3, I have 4 I's. And I've also got 2 P's. So let's talk about what to do with those repeats at the bottom. You are going to be multiplying them, not adding them. Now you can do this by hand or you can use the calculator. It's up to you. For this type of problem, I'm going to use the calculator. So 11 and then probability, factorial, divided by, now in parentheses I have to do 4 factorial times 4, don't put 8, you can't add them, okay, they're not like terms, times just 2, right, because that's 2 times 1, I don't need to go searching for a factorial. And so I end up with 34,650. Now if you don't have a calculator on hand, the other option would be 11 times 10 times 9 times 8. Okay, so that will get rid of my first 4 factorial. But, hold on, I'm sorry. I'm going to put times 3 times 2 times 1 times 2. So 8 over 4, that leaves me with 2, and then these 2's would cancel. The 3 times 2 and the 6 cancel. So you could have done 11 times 10 times 9 times 7 times 5 and gotten the same answer. And let's check that. 11 times 10 times 9 times 7 times 5. And you still end up with the same answer. So 2 ways to do that one. I'm going to move on to another example that is slightly different than that, but is operated the same way. So I think we're on example 4. So let's say Arroyo has 10 marbles. 3 are red, 3 are blue, and 4 are green. How many different permutations or orders can he form with these marbles? So this is set up different. I don't have the letters, but you do. So think of it this way. I have 3 red, 3 blue, and 4 green. So you can turn it into a letter problem. It doesn't form a real word like Mississippi or Michelle, but it's like the ABCD problem, right? This doesn't form a word, but we still have letters. So I have a total of 10, correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divided by my repeats. Okay, and you can do this by hand. 10 times 9 times 8 times 7 times 6 times 5 times 4 factorial. 3, 2, 1. I don't need the 1, right? 3, 2, 4 factorial. So this 6 and 3 times 2 are out. 8 over 2 is 4. 9 over 3 is 3. So I'm left with 10 times 3 times 4 times 7 times 5. And so I get 10 times 3 times 4 times 7 times, I get 4,200. Now you should get the same answer if you use parentheses at the bottom and multiplied. So it's really up to you how you would like to input these problems. But that pretty much covers any section you should, or any problem you should see from this section. So for the homework for 55, skip numbers, I want to make sure I write these in order, 6, 7, 19, 23 through 25, and 27. Thank you.